Hi guys, good morning. I hope you are able to hear me. Can anyone please confirm? Okay, perfect. So in the last session, we have seen how we can create a data frames and how we can apply the data restriction based on the conditions. And we also came across how we can use the varieties of the functions for restricting the data, for creating a columns. And we came across even data aggregation also, how we can do the data aggregation with the help of data frame functions. Okay, so if I wanted to write a SQL code, okay, so how exactly we are going to do that, I'm going to take you through, and how we can create a tables. I mean to say how we can create a external tables that I'm going to take you through at the time of project. Okay, so creating a tables, we'll see there, and here I wanted to create a view. I wanted to create a view in the database. So when you create a view, there are two different options are there in order to create a view. So let me take you through that, how exactly we are going to handle it. There is a function called data frame dot create or replace temp view name you can specify. So I wanted to say it is used to create a view by using a data frame. So view will be created in hidden database. So you cannot see that. In a hidden database, it is going to be created. Okay, so in SQL Server also, like if you are having a knowledge how we can create a view in SQL Server, the way we create in a SQL Server, in the same way it is going to be looks like, but way of creating is little different. Okay, so if you create a view here, let me connect to SQL Server. If I execute this, I'm getting this result. I can create a view for this. In SQL Server, how we can create is create view v underscore employee underscore as that's all. So this is how we can create it. In the same way, we can also do that, but I wanted to do it with the help of data frame. I mean to say data frame API. So let me create it. When I create this one, v is created, and I don't execute all this stuff. I'm just going to say select star from v underscore employee data. So in the same way, I wanted to write with the same name in the data frame also. Okay. So for that, I'm just going to create this data frame I require to create it. That is df1. The df1 result is this. On top of this result, let me say final underscore df equals to. So I required this data frame. I guess we already created. Let me start this. I'm going to say we need to create a cluster. Now cluster is ready. So let me create this data frame also. Because on the aggregated data, I'm going to do this. Not this one. Yeah. So I'm having the data in the final data frame. Let me say display of final DF. Now you can see this result here. And I wanted to create a view on top of this. So if you want to create a view on top of this, then you can just go and create a view. So there is a function called create or replace stamp view, and it will be created in the hidden database. And this view will be available for this session only. So that means for this particular notebook only, it is going to be available. It's not going to be available for other notebooks because it is a temp view it is. So now I'm just going to say there is a one more function. Let's come across that. So final underscore df dot create or replace temp view. So temp view name is v underscore employee data. So let me keep this in a double quote. Now v is going to be created. Now v is created. Now if you wanted to read the data from this view, then what you have to do is to read the data from here, to know the data, what data is available here, then you can use this display function. Right? In the same way, now I have the data in the view. I have a data in the view. So in order to have the data in the view, if data is there in the view, then how we can read the data from the view. Okay, so how can you read the data from a view or a database? So we'll see that database, how we can use this database or how we can create this database at the time of project. So very soon we are going to start our project so that we can get better clarity. And how can you read the data from the view, even if it is there in the database? So here at this point, at this particular place, I'm not showing how we can create a database, but we are going to see how we can create a database as part of the project in Azure Databricks, not with the community edition. Now, I wanted to read the data from this view. So if this is the case, then we need to write as Spark SQL to read data from a view, a table, or database. So that means when there is a table or view, that will be there in the database. Okay, and applying transformation we can do with the help of Spark SQL. We can write the Spark SQL in order to do it. Okay, so to execute Spark SQL commands, use the following ways. By using percentage SQL. Okay, so by using percentage SQL, you can write pure SQL code. Okay, the second is by using spark.sql function. Okay, so here also we are going to write the SQL code. Inside this spark.sql, we can write a SQL code here. SQL code here. Okay, so here after this SQL code here. So if you remember, we already come across the SQL code. In SQL Server, I explained about how we can join the two tables and how we can do it. All those things, we came across it. Now, if you want to read the data from this particular place, how we can read the data here is, you can say, I'm just going to say percentage SQL, lowercase characters. When the moment I use this one, you can say that is going to be treated as a, let me keep in a different cell because this is not going to take as a common. Let me say here, percentage SQL. So when the moment I take this percentage SQL, this is the magic commands, we can call them as this. Or you can also go and change the language from here. So default is Python, and you can move to any of these languages. Now it is there in a percentage SQL, SQL standard, it is available. Now I wanted to say here, select star from v underscore employee data. Let's execute it. Now you can see. We're writing the same statement only. Same statement, right? So it's a SQL statement. Okay, so this is a Spark SQL. Okay, so in order to get this result, we applied all this aggregation, right? This are all the things we have done. So instead of that, I'm going to create a data frame for this, somewhere it is. For dpt underscore df, I'm going to take for emp underscore df also, I'm going to create a 2 ways. And then I'll create a transformation, how we can do transformation by writing the SQL code. I'm going to show you. Okay, so the task is 33, 34. Create views on emp underscore df and dpt underscore df. Apply aggregation and joining on both of the data frames. Create another view on top of step 2 result. So this is what I wanted to do here. And I'm already having that emp underscore df. So I'm just going to say emp underscore df dot create or replace temp view. So here I'm just going to say v underscore employee And one more view is required, that is the department. So I'm just going to say v underscore department. So here it is a dpt underscore df. So when I execute this first step will be created. Okay, so two ways are created, and then I wanted to apply the aggregations. Okay, so to apply the aggregation, you can go for next cell also. Let me execute up to here. Now views are created, and I wanted to write a SQL statement. You can, I mean, it's a Spark SQL. We already talked about how we can join the two tables, right? Let me apply first aggregation on top of this. If we say select star from a view name, now you can see all the data here. I don't need all the data. I need only this result I wanted to get. So department number, salary, count, average salary, min salary, max salary. I wanted to take it. So for that, you can just take a department number. If you execute, then it is going to get only department number and then salary. These two columns are required. Rest of the columns I don't need. Now you can see. So from this tables, from this columns, you have to create. I mean to say, you have to calculate all the aggregations. You have to create all the aggregations. Now I'm just going to say department. Let me say here sum of salary as salary. Now when you have this sum, then definitely you need to have a group by class, right? That you know it. Group by department number. Let's execute it. Now you can see the sum salary. You can see the sum salary. And I wanted to say comma count of employee number, or you can take a star also as e count average of salary as average salary, min of salary as min salary, max of salary as max salary. Let's execute it. Now you can see the same result we are getting here, and this department name and locations are not available here. So those two are available in different place, right? In a different view it is available. Okay, so let it be as this. I'll say you here, I'm just going to take one more cell for the department. No, for this one, I wanted to create a city, common table expressions. Okay, so we talked about common table expressions in SQL Server. The same to same, there is no change. If you go to the aggregated functions that we came across to discuss, it's same to same only. There is no difference. So instead of doing this entire thing, in order to do aggregation, you have to remember all these things. You have to do like this. But if you can go with the SQL, it is very much simple to do it. Now this one, I'm going to keep it in a city with city underscore employee, and just saying as open a brace and close it brace. I don't think we required. Okay, let's try. So now I'm just going to say okay, so let me try select star from city underscore employee. So when I execute this, it has to get that same data. Now you can see the same to same. So this is a CTA and we are reading data from the CTA. So once you have done the aggregation, the CT is going to join with the department data frame. So I'm just going to say here A inner join V underscore department D on E dot department number equals to D dot department number. D dot department number. Okay, so I guess the same column name. Okay. So now if I execute this, then you can see the result. Your department number, location also is coming. So I'm just going to keep in a same order, whatever the order I need. So I just wanted to say A dot department number, comma, and D dot D name, D dot LOC, E dot salary, E dot E count, E dot average salary, E dot min salary, E dot max salary. That's all. Okay, so you can write the SQL code like this. So just SQL statement on. You can keep the star also, but I wanted to keep in a same order. So I'm just going to execute the statement. You can see the same result. So this result, if you wanted to keep it in a view, you can keep it in a view. You can create a view on top of this. Okay, so let me say here, let me try to keep that as well. Not sure, will it allow or not. EMP underscore AGR as, let me create it. This will not allow. Okay, so we have to go for different approach to create a view again, because as we're having a CTA. So if you don't have a CTA, then we can create a view. Let me take this copy of this in a different approach I'm showing. Just take this. So without CTA, I can go for this as well. So this entire thing, I'm just going to keep it in another select statement, select star from table name. Let's give this as a T. Now execute it. It's a subquery style it is. You can see the same result and inner join with v underscore department. Let me take the join condition. Let's say this is a E and this is D, and take a condition. So E inner join with V department E and this particular conditions. If you try to execute this, now you can see all the columns are there. On top of this, you can write one more select statement to have this list of columns. Or you can directly create a view. Okay, so let me say, let's try create a view. Emp underscore data as, let's execute it. Okay, understand. So it will not create a permanent view. You are trying to create a permanent view. There is a temporary view create. Okay. So department number is there in both the places, so it is making a problem. So what you can do is, I'm just going to take this list of columns here. You have to create one more select statement on top of this, then only can get, because department number is there in both the places. So for time being, I'm just going to say E dot department number, I'm saying, and here you need to give a list of columns. So E dot star, comma, D dot D name, and D dot LOC. So these columns are enough. Let me try again. Now it is created. So if we go and see the data from the EMP data view, let's say SQL, select star from a view, let's execute it. Now you can see this. Okay, so the order of the columns I've taken, there is no much perfect order. We can change this. So I've taken E dot star, right? So we can keep that E dot department number and something like this. E dot salary, E dot E count, E dot average salary, E dot min salary, E dot max salary. Okay, so create or replace, we can take it because we're replacing it. Let's execute it. So now if we go and see the data, we'll be having the order what we are expecting. What happened? I understand. This one has to be here. Let's execute it. Now you can see the way we have a result, in the same way we have a result here. So if you want to create a temporary view, you can use create a temporary view. So this temporary view is going to be available for only this particular session. So this is how we can create a view here, and with data frame dot temporary view also we have it. Okay. Apart from that, there is a one more view, that is global temporary view. Okay, so you can use global temporary view also. emp underscore df dot create or replace. You can see there is an option called create or replace global temp view. Create global temp view, create temp view, create or replace. So if it is one-time creation, then you can go for create temp view. Mostly in real time when you're working, mostly we're going to take a create or replace, because if there is any definition is changed, then it will be the better option. So you can go for create or replace. So create or replace temp view or create or replace global temp view is going to do the same thing. Only thing is the V is going to be available in other notebooks also. In other connections also it is going to be available. Okay, so you can take this and you can specify a view name V and global temp view. Let me say global temp view underscore employee. So I'm just going to keep that in a double quote. So on the same employee data frame, I'm just creating it here, and you can use this. It is used to create a view, and it will be available for other sessions also. Now let's execute this. Now global temporary view is created, and if you wanted to see the data from here, then you can write it, same thing. Like let's go for SQL here. Select star from a view name, execute it. What is this? Okay, I understand. Correct schema and catalog. So this is the problem. Okay, so I'll show you this one with Azure Databricks so that it will be easy for me. I'll create a database and we'll see, but here it is not allowing me to extract it. So we'll see that. So basically the intention of this is it is going to be available for other connections also when you go for global temporary view. And I have already this view, right? What is that view? v underscore okay, let me create a replace time view. So here I'm just going to take time view underscore employee. Select star from TV underscore employee. So I'm having this employee details here. So I wanted to say the top highest salary. Okay, so top highest salary, I wanted to find it. If you wanted to find the top highest salary, then how we can get the top highest salary? Let me show you here. Write a SQL code to get top highest salary. So it's the same the way we have done in SQL. It is going to be very much similar. So I'm just going to say here, select star comma. Dense rank, we have a dense rank function. You can use that over order by salary and descending as rank. So if you execute this, it is going to get the ranks. Now you can see. So 5,000 is 1, and you can see 3,000 is second rank, 3,000 is also second rank. Okay, so let's say second highest salary. So write a code to get the second highest salary. So dense rank function we are going to use in SQL standard it is. Okay, so dense rank over order by salary descending order. And you can see the first 5,000 is rank 1, 3,000 is rank 2, 3,000 also is rank 2. So wherever there is a same value, the rank number is same. You can see 1250 is there in 3 times. So rank is same to same you are getting here. Okay. And if I go for dense rank, if I go for, let me say this is dense underscore rank. We can also have a same thing. There is a function called rank function also. There is a function called rank also. So I'm just going to say rank underscore rank and dense underscore rank. Just execute it. So you can see first 5,000 here, rank 1. If you go for rank, you can see, concentrate on this. So 5,000, rank function is giving 1 and dense rank is also having 1. I don't have any problem. But when you see this 3,000 here, oh, yeah, that's fine. Now when you see this 3,000, the rank is giving 2 here for both of the values. That is fine. I don't have any problem. And dense rank is also giving same, that is second rank, because these 2 people are getting same salary. And the fourth record, if you see here, 2975 is there. The rank is going directly to 4. It is skipping. It is skipping this 3. It is skipping the 3. One rank is skipping and it is going for the next rank. That is 4. But here it is showing 100% is correct. Okay, so that is the difference. Here, here it is going to skip if there is a same rank. If you have more than one record with the same rank, then it is going to skip one time here. But here it is not skipping, it is giving as it is perfectly. Now there is a 1250 also is there. The rank is 9 here. Sorry, 10 here in the rank function. But in dense rank it is 9. So here also it is 9 for this. Sorry, it is also 10. So here also 9. That is fine. Even for this particular place also it is fine. But when you come to this rank function, now this time it is jumping to 3 times. Okay, so that means 11, 12 it is jumping and it will go for this. Because here we have a more than 2 is available here. Okay, so when there is a 3 minus 1 times it is going to jump. And here it is giving 100% correct answer. Because all these people are getting same rank. And 1100 is the next rank. So we cannot say that is a 13th rank. Okay, so then there is a chances to ask what is the difference between the rank and the dense rank function. And if they ask the second highest salary, how we can get it, then we can say we are going to use the dense rank function. And based on by using dense rank function, we can order the salary, and then if I need only the second highest salary, because here it is showing all the data, I don't need all of them. So what you can do is you can write a select statement on top of this again. Select star from, give a bracket open here. And just closing this brace. Let's say T, where T dot dense rank equals to 2. Let's execute it. Now you can see the data for only rank 2. Okay, so if you wanted to specify the list of columns, you can specify the list of columns here. Okay, so for this, with this particular code, I wanted to create a data frame. With this particular code, I wanted to create a data frame. So before going to this, I wanted to explain one more thing. Write a SQL code to get the second highest salary for every department. So here it is going to get partition by department number. Okay, I'm just checking this particular value only. I don't need rank function. For every department, I wanted to get it. For every department, I wanted to see the second highest salary. Let's execute it. Now you can see in department number 10, second highest salary is this one, and department number 20, the second highest salary is this, and department number 30, this is the second highest salary. So you can cross verify also if you wanted to cross verify. So this entire result set I wanted to create in a data frame. I wanted to create a data frame for this entire result set. Okay, so I'm just giving task 35. Create a data frame by using second approach. Second approach is what? I'm just giving final underscore df something. I'm just giving any name you can give it. Spark.SQL. So here what we have to do is, so 3 times double quote you have to give. So in between this, you have to keep the SQL code. So whatever the SQL code you wanted to keep, you can keep that. Now If I execute this, it is going to create a data frame. Now data frame is created. If I display this data, display of data frame. How can I say? So I wanted to store this data in the target. So if you wanted to store the data in the target, then you can use same. We have come across that. So apart from the reader, apart from the data frame reader, you can use a data frame writer. You can use it. Just give me a minute. Final df dot So when you go for reading, you can use the spark.read format. You can use. So in the same way, more or less same kind of approach you're going to do it here. So in data frame.write, under the write, you have to specify what type of format you wanted to take it. So I wanted to take the format as CSV because just for readability, I wanted to take the CSV. Okay, so otherwise you can take a Parquet file format here. Okay, so it all depends on your requirement. You can do 99% we are going to take a Parquet. And do you want to keep the header or not? Let me keep the Parquet only. Data frame dot write dot format and Parquet I'm just taking, and then dot save. So where do you want to save? I wanted to save this in the file store. Inside file store, we have a ADA02. How exactly it is this? ADA02. So here I'm going to have a target folder. Inside the target folder, I wanted to say employee underscore second rank. I'm just giving some name for that. Okay. So I can give some path for that. So that is more enough. And then I wanted to execute this. Writing data to BBSR from data frame. So if you have a data frame, you can take any data frame. So here I'm taking this data frame after executing this SQL code. Okay, so you can take employee data frame, you can take whatever the data frames we came across it. You can use all of the data frames in order to store the data in the target. So I'm just executing this. Now, if I wanted to read the data from here, what you can do is, I'm just going to create a one temp df equals to spark.read.format Parquet dot load. You can specify this part of the file. I'm just going to say a display of temp df. Let's execute it. You can see the data. So if we go to the DBFS here catalog, DBFS, go to your target. Under target, just now we created this emp underscore that. You can see there is a part file is created. So like this, we can load the data if you wanted to load the data. Okay, so mostly we are going to start the project from tomorrow only, so that we can see how exactly we can take the data from the different places, and how we can create a external tables. I mean to say Spark tables, how we can feed the data into the Spark tables, that we are going to see. Okay. So I'm stopping here. If you have any question, you can ask me. You can unmute yourself.
Sir, how much tentative days are left for to complete?
Next 10 days.
So Synapse and all that will cover.
Synapse, I'll give a basics only. Okay, so Synapse is the combination of Data Factory and Databricks.
Okay. Synapse and that Microsoft Fabric. Are you going to cover?
No Microsoft Fabric.
No, you are earlier you told something you idea about.
I'll give an overview, but
Okay.
again, setting up all those things, again, different course it is actually. Okay, so and we are planning.
You give an overview. Means,
yeah, I'll give the overview.
Okay, thank you.
Yeah. Anyone else?
Sir, I have one doubt.
Yeah.
Sir, can you read store criticism as well?
Can you repeat again?
So can we read the store procedure as well here in the data frame?
Your voice is little.
Okay, 1 second. Am I audible now?
Yeah.
So can we read the store procedure as well here?
No store procedure.
Okay, only select statements.
Yes.
Suppose if you want to update any data, so that will be reflected in database as well.
We are going to talk about it as part of the project. We'll see. Spark table, if it is delta tables, then only it is going to be possible. If it is not a delta table, it's not going to be possible to update. We have created a view, right? We cannot update the view. Only if it is a delta table, then it is possible to apply. So there is a delta lake in the Databricks. So we are going to see as part of the project. So delta tables are going to be allowed.
Okay, apart from delta, we cannot, suppose let's say we have Azure SQL and on-prem SQL. So those cannot be possible to update.
Why Azure SQL?
Suppose let's say if you want to update something, so
the way you are updating, the way you are applying DML operations in SQL Server Oracle, the similar kind of things we can also do here, but that table should be a delta table.
Okay.
Okay, so how do we know that is a delta table? That we are going to see.
Okay, got it, sir.
Okay.
I have one more issue, sir. While reading the JSON file using a schema, so the syntax and everything perfectly fine. So whatever there in class. So the same syntax working for you, but it's not working for me, sir. So is there any alternative way to check the syntaxes? Like
can you check that multi-line? Did you have that
multi-line true, sir? Yeah, multi-line true.
Is that?
Yeah.
Okay, so if you can share the screen, then we can see.
Yeah. One time from here. I think
yeah, now you can try.
Okay. I hope you are demonstrating screen, right?
Some format, multi-line true, load. So what it is getting? What is the
Right now I just did. I mean, because
no. Schema you should not define outside because it comes with the schema. The file itself comes with the schema. No. The file itself, the JSON file itself, having the schema.
Okay.
So we don't need to specify.
Yes. So not required to specify.
No, not required.
Okay.
Okay, so it comes as a schema, so we don't need to specify it.
Okay, fine, sir. Yeah, I think probably I made a mistake.
Yeah. Okay, anyone else? Yes? Anyone having any doubt?